Okay, so welcome to your second video about the aerobic profile lab assignment. Today we're going to look at the part 3 and part 4, so steady state and VO2 max. Before we do that, we're just going to have a quick recap about 1 and 2. So as you can see on the screen, we've got a number of different ways that we can display the data that we've been asked for in question 1. So we've got a few different tables, graphs that you can see here. So we've got a collation of the important things, so the names, what level they've reached, the max heart rate, the resting heart rate, what the heart rate was after they've recovered, and their predicted VO2 max. Here you've got a graph that displays the VO2 maxes of all the individual athletes. It's got the difference between males and females here. Then on this one, we've got the heart rates during the activity. So you can see that they're all steadily going up. And then we've got this line going right across here. That's our anaerobic threshold. So we've calculated the anaerobic threshold and just put it right along there. Then we've got this one here, and that looks at the recovery rate. So what happens after they've done the exercise. So after they've done the beep test, during the beep test, and then after the beep test here. So this decline, and then it levels off. So there's a few different ways that we can display the data as a graph rather than a table. And that helps us to indicate the anaerobic threshold, look at the predicted VO2 maxes as well for each individual. Then question 2, we've got defining the anaerobic threshold. So how do we actually calculate that? Which I ran through in the previous video. So if you go back to that one, you can see how it's calculated. And then, do athletes reach this point, and how often, and how could they train to improve it? So if we look at this particular graph, we've got anaerobic threshold going across there, and we've got every athlete reaching anaerobic threshold at some point except this one. So how do we train to improve it? So here we're going to look at a few different things. Here we've got the different types of training that we can utilize in order to improve things. So you can go back to a couple of different videos that I've already done. So we've got the video on the methods of training, might help you, and the video of long-term effects of exercise. No, that's what I spelled that. Long-term effects of exercise. So what happens over a period of time. So these two videos will help you here. So we're looking at what we want to change and which type of exercise might we be utilising in changing that. That's 1 and 2. The next bit is steady state. So what is steady state? And it's about the amount of oxygen that we take in and use, and how it needs to be equal to the oxygen demands of the exercise. So as part of, on this graph here, you can see that the heart rate kind of levels off here. It goes between 154, 158, 155, 160, 155. So in this particular area, it's pretty steady. So it's pretty flat. And that means that the oxygen being taken in and delivered and used is about level to the type of exercise that's being done. That's not for the data that you've actually been given. So that's just what steady state would actually show. The thing about the multi-stage fitness test is that it's a progressive test, which means it gets harder every lesson. So if it's getting harder every lesson, what's happened to the intensity? And then what should be the short-term effect of your heart? So what should happen to your heart rate as each level gets harder? Okay, as you can see here, it gradually goes up. So level 1, it's there, level 2, it's there, level 3, it's there, level 4, it gets harder, level 5, it should get harder, level 5 and 6, it should get harder, 6 and 7, it should get harder, 8, it should get harder, 9, it should get harder, 10, it should get harder. If we go back to this graph here, what happens to most athletes there? What's happening to the heart rate? Okay, what's the trend there? So that's what should happen as the intensity changes. And then the part C to 3 is there any evidence to suggest that steady state has been reached by any of the athletes? So that's when we need to look at the data and say, look at our graph and say, well, actually, not really. That could be because the beep test gets harder every level, so that every minute. So that means the heart rate has to work a little bit harder every minute, and the oxygen demands are higher every minute. So technically, steady state might not be able to be reached. Then we've got VO2 max. So the predicted VO2 maxes of each individual. We can define them again using our brianmac.demon.co.uk website that we talked about in the previous video. That's just simply a copy and paste type of activity. And then we can compare the VO2 max of the athletes and explain your findings. So what can you see here? What patterns can you see? And what facts can you pull out about these findings? And then we'll look at why might that be the case. So we're trying to explain them away. So we can state that James's predicted VO2 max is about 55. If we looked at our table, James's VO2 max is 54, Jared's is 48, Eddie's is 41.4, Sam was 54.8, Luke was 49.3, Donna was 33.6, Amelia was 30.7, and Morgan, who was the best performing female athlete, was 43.9. So what can you say about these three results compared to these three results, and why might that be the case? Why has Sam got a higher VO2 max than anybody else? Why might that be the case? So you can look at that and try and pull together some statements and some ideas as to what that might actually be going ahead. So far we've got these different ways of looking at the information, tables, graphs. Then we've got how we can calculate anaerobic threshold and how we can train to improve that anaerobic threshold, what method of training we might use. So continuous interval fartlek, plyometric circuit training, weight training. Which one of those is going to be the best for developing our heart and lungs and the cardiovascular system? So these two videos might help you there. Then we've got steady state. So what does steady state actually mean? Can you see it? If you can, why can you? If you can't, why can you not see it? So we're trying to explain those results away. Then we've got predicted VO2 max. What can you notice about these things? What do you notice about the average for males and females? What do we notice about this particular group of females? It's only a small group, but what do we notice here? What do we notice about this particular group of males? Again, it's only a small number, but is there something that you can notice? Why do you think that these 5 males are above the average for males? Well, these are our top performers maybe in sport, so we could be saying that generally these are fitter than your average person. Or it may well be that this particular person is a 6'10" monster, whereas this particular person can be 5'8". Sorry, 5 foot nothing. So there's a difference there. So it's just ways of explaining those results away. The next video that I'll do will look at using the data and explaining the interplay of energy systems, and it will also look at the physiological factors that you're going to seek to improve. So it's going to refer back to this particular video here and this particular video here. So we're going to tie in, we're going to do a little bit more work on this area. So how we can actually utilize our principles of training as well, and our methods of training. So you've got previous videos that you can go back to get information from. If you've got any questions, please ask, or you can comment on these videos and I'll get back to you. And finally, remember, don't forget to subscribe.